Welcome to our Allied Lecdem channel. Today we are going to see the development of the heart. The heart is the first organ of the body to start functioning. The heart is first seen in the form of right and left endothelial arch tubes that soon fuse with each other. Then, the single tube formed in a series of dilatations from cranial to caudal end into four parts, that is, bulbus cordis, primitive ventricle, primitive atrium, and the sinus venosus. Cardiac septations to form a definitive arch occur between the fifth and the eighth week, and fate of the various parts of the heart tube can be seen in upcoming slides. Sinus venosus. This is the most caudal part of the primitive heart tube. It presents a body with two prolongations that are referred to right and the left horns. They consist of one vitellian vein from the yolk sac, one umbilical vein from the placenta, and one common cardinal vein from the body wall will join each horn of the sinus venosus. Initially, these horns are of both equal sizes. Due to left to right shunt, most of the blood drains into right horn of the sinus venosus. Communication with atrium. The sinus venosus and the primitive atrial chamber are connected by the sinoatrial orifice. However, they become partially separated by the grooves that appear on the lateral wall of the heart tube at the junction of these two chambers. Regression of the left horn and its tributaries. The right groove remains shallow, but the left one becomes very deep so that the left part of the sinus venosus becomes completely separated from the atrial chamber. Simultaneously, the left horn of the sinus venosus and its tributaries become much in reduced size, and finally the left horn remnant becomes the part of the coronary sinus. Change in size and orientation of the sinoatrial orifice. Initially, the sinoatrial orifice is larger in size, transverse in orientation, and median in position. Then it changes to oval, finally to the vertical with narrow slit. These slit as right and left margins called as right and left venous wall. Cranially, these two wall fuses to form the septum spurium, and caudally it forms sinus septum. Fate of right and the left venous wall. The right margin of the original sinoatrial orifice expands very greatly and divides into three parts by two muscular bands, that is, superior and inferior limbic bands. The three parts of the right venous wall are crista terminalis, valve of inferior vena cava, and valve of coronary sinus. The left venous wall get incorporated into development of septum secundum. Fate of tributaries of sinus venosus. The right common cardinal vein becomes the part of superior vena cava, while the right vitellian vein forms the terminal part of the inferior vena cava. Formation of atrioventricular canal. Generally, the AV canal is circular in shape initially, and later it becomes transverse. There will be two AV endocardial cushions appear on the dorsal and the ventral wall of the AV canal by proliferation of subendocardial mesenchymal cells around right and the left AV canals. They grow towards each other, and these fused cushions form the septum intermedium and finally take part in formation of the interatrial and interventricular septa. Formation of interatrial septum. The atrial chamber undergoes division into right and the left half by formation of two septa. First, appearance of the septum primum. Notching of the ventral wall of the primitive atrium occurs because of pressure of the bulbus cordis, which results in formation of sickle-shaped fold. This fold is called septum primum. It is located exactly in the midline, and it is to the left of the septum spurium and ultimately fuses with the septum intermedium. Second one, Appearance of ostium primum. Before the septum primum reaches and fuses with the septum intermedium, blood flows through the gap between them. This gap is known as foramen primum. Third one, appearance of ostium secundum. Before the foramen primum can be closed, it is essential that another path for blood to flow to be created. This is achieved by breaking down of upper part of the septum primum. This new gap is known as foramen secundum. Fourth, appearance of the septum secundum. The septum secundum grows down from the roof of the atrial chamber to the right of the septum primum. As it grows, it comes to overlap the free upper edge of the septum primum. Fifth, appearance of foramen ovale. Once the two septa overlap, blood has to flow through the interval between the septa. This gap is known as foramen ovale. It is an oblique valvular passage that allows the blood to flow from right to left but not from the left to right. This is patent throughout the fetal life. Sixth, obliteration of foramen ovale. After birth of the baby, the left atrium starts receiving the oxygenated blood from the lungs. The pressure of this chamber becomes greater than the right atrium and there is no need of blood to flow from the right atrium to the left atrium. The foramen ovale is therefore obliterated by fusion of the septum primum and the septum secundum. Development of the right atrium. The main right atrium is derived from the three sources. They are: first, the right half of the primitive atrium. It forms the rough trabeculated part in front of the crista terminalis, including the right auricle. Second, absorption of the right horn of the sinus venosus into right half of the primitive atrium. This forms a smooth part behind the crista terminalis developed from the absorption of the right horn of the sinus venosus into right atrium by great enlargement of the sinoatrial orifice. Third, absorption of the right half of the AV canal. After absorption of the sinus venosus into right atrium, the coronary sinus and the vena cava are seen opening into the atrium. The expanded right venous wall, that is partitioned by two limbic bands, become the crista terminalis, valve of inferior vena cava and valve of coronary sinus. Development of the left atrium. The left atrium is derived from the following three components. That is, first, the left half of the primitive atrial chamber forms the rough anterior part and the left auricle. Second, the left half of the AV canal forms the anterior smooth part. Third, absorbed proximal part of the pulmonary vein forms the posterior smooth part between the openings of the pulmonary vein that forms the anterior boundary for oblique sinus of the pericardium. Absorption of the pulmonary veins into the left atrium. At the time when the septum primum is just the beginning to form, a single pulmonary vein opens into left half of the primitive atrium. When traced away from the heart, the vein divides into right and the left branch, each of which again bifurcates to drain the corresponding lung bud. Gradually, the parts of the pulmonary vein nearest to the left atrium are absorbed into the atrium with the result that four separate veins, two from each side, come to open into it. Development of the ventricles. The right and the left ventricles are formed by partitioning of the primitive ventricles and incorporation of the bulbus cordis. Bulbus cordis. The bulbus cordis is the most cranial part of the developing heart tube. It is divisible into three parts: proximal, middle, and the distal. The proximal part merges with the cavity of the primitive ventricle and forms the bulboventricular chamber. It takes part in forming the trabeculated part of the right ventricle. Middle part. It forms the outflow part of both the ventricles. Two septa are formed in relation to the wall of this part. They are proximal and the distal bulbar septa. The proximal bulbar septum contributes for the formation of the interventricular septum, and the distal bulbar septum separates the conus into aortic vestibule and the infundibulum. The distal part undergoes the division by spiral aortopulmonary septum into ascending aorta and the pulmonary trunk. The spiral septum is formed by the union of right superior and left inferior truncus swellings. Orientation of these cushions. Proximal part. It forms the coronal orientations and continues with the distal bulbar septum with the result that the pulmonary trunk is anterior and the aorta is posterior. In intermediate part, anterior-posterior orientation takes place with pulmonary trunk on left side and the aorta on the right side. At last, in distal part, again coronal orientation takes place where the aorta is in anterior and pulmonary trunk is posterior. Formation of the interventricular septum. The ventricle cavity formed after the conus and proximal one-third of the bulbus cordis has merged into the primitive ventricle and has to be subdivided into right and the left half in such a way that each half communicates with corresponding atrium. The subdivisions takes place as follows by formation of the interventricular septum. They are muscular part, bulbar part and the membranous part. Muscular part. A septum called interventricular septum grows upwards from the floor of the bulboventricular cavity and divides the lower dilated part of this cavity into right and the left part. Passive dilatation of the bulboventricular cavities on either side of the septum takes place. It meets the fused AV cushions and partially fuses with them. The cephalic margin of the septum is free, concave, and twisted and presents a dorsal and the ventral horn. The dorsal horn fuses with the right edge of the dorsal AV cushion, while the ventral horn fuses with the left edge of the ventral AV cushion. The closure of the interventricular foramen is facilitated by the septum intermedium and proximal bulbar septum. Bulbar part. Two ridges, termed as the right and the left bulbar ridges, arise in the wall of the bulboventricular cavity. The right ridge arises from the dorsal and right wall and is cephalic to the right AV orifice. The left ridge arises from the ventral and the left wall. These ridges grow towards each other and fuse to form the proximal bulbar septum. Membranous part. The gap between the upper edge of the interventricular septum and lower edge of the bulbar septum is filled by proliferation of the tissues from right side of the AV cushions. The membranous part of the interventricular septum is divisible into an anterior part which separates the right and the left ventricle and the posterior part which separates the left ventricle from the right atrium. The interventricular septum is probably formed more by the downward enlargement of the right and the left ventricle cavities on either side of the septum rather than by active growth of the septum itself. Finally, development of the right and the left ventricles. The inflow part of the both ventricles are formed by the corresponding part of the primitive ventricle. The outflow part, that is, the infundibulum of the right ventricle and the aortic vestibule of the left ventricle are formed by the middle one-third of the bulbus cordis, that is, the conus. At last, the conus form the outflow tract of both the right and the left ventricles. Thank you.